Well, we'll get into more detail about some of these mechanisms as we go through the rest of this module. I wanted to give a brief introduction to some of the mechanisms of interaction that you'll come across in chromatography. The first, and one of the more common, is adsorption. Now keep in mind this is adsorption, not absorption. It has a D in it. Okay, adsorption. And in this process, you're looking at a stationary phase here. So here's my column. I'm just going to draw my stationary phase like that. And as my analyte is passing through the column, it's going to kind of stick to the surface. And that process of sticking to the surface and then coming off of the surface and continuing to move through the mobile phase is going to be what leads to a separation. The ones that stick the hardest to the surface are going to be the ones that take longer to make their way down the column. I kind of think of this like window shopping. Someone who does a lot of window shopping is going to take forever to walk through the mall because they have to stop and look in the window of every store. But if you have someone who doesn't like to window shop and they're like really focused and like just got to get through this mall, they're going to take a lot less time because they're not going to stop at each window. And so I kind of think of adsorption in this way of pausing to stop at the stationary phase. And how long do you spend stopped at each station, at each kind of interaction with the stationary phase? Okay. Now in adsorption chromatography, our stationary phase here is typically a solid, and we can have a mobile phase be either a liquid or a gas. Okay. So that's the first type, that's adsorption chromatography. The next type of mechanism that we can have is called partition chromatography. Now, in this case, what we end up having is a bonded liquid as our stationary phase. So here's my column, and I have this thin layer of liquid as my stationary phase. Okay, so in this case, the stationary phase is a liquid bonded to a solid surface or solid support. And so what happens in partition chromatography is that as my analyte comes down and interacts with this liquid, it's not just adhering to the surface like it did in adsorption, but it actually can diffuse in and then diffuse back out and keep moving. And then it can diffuse in and diffuse out and keep moving. Okay? So as it's moving down this column, at each point that it interacts with the stationary phase, it's actually kind of dissolving in the liquid and then coming back out into the mobile phase. And so the mobile phase here is typically either a liquid, or we can do this as a gas as well. Okay, so that's partition chromatography. The next type that we'll cover, and we'll actually cover this a little bit more in the next module, is ion exchange. And here what you have is a solid support. You've got a stationary phase that is a solid resin. Now what do I mean it's a resin? So a resin is a hard amorphous solid, and this particular resin has anions or cations covalently attached. So because they're covalently attached, it gives this surface kind of a net charge. So let's say this is a net positive charge. It's got these cations covalently linked to the surface. And so in ion exchange, anytime you have a positive cation, you've got these kind of negative counter ions. And when our analyte comes in, our analyte would also be negatively charged. I'll give it a little A to show that this is an analyte. And what this can do is kind of come in, see the positive charge, and kick off a negative charge. But there are other negative charges in solution that are going to come in, kick off the analyte, and the analyte will return to solution. Okay? So that's kind of the process for ion exchange. And again, we'll get into more of this when we talk about ion exchange in the next module. But the mobile phase for ion exchange is always going to be a liquid. The next type that we're going to do is molecular exclusion. And there are actually groups that are going to talk about the theory for this as part of their group project. So I'm going to leave molecular exclusion here and let you kind of use this as a teaser to say, oh, this is another type of chromatography that we're going to see come group project time. But I will talk a few minutes, or just briefly, about affinity chromatography. And affinity chromatography involves a very specific interaction between the analyte and a molecule that's covalently linked to the stationary phase. So much like with ion exchange, you have the stationary phase, and we covalently link some kind of a specific compound. Okay? Is a solid with molecule covalently linked. And so what happens here is that you get your analyte coming in, and if the analyte fits perfectly to match up with your with the molecule of interest, there's a specific attraction going on here. And that's what's going to lead to the separation of one analyte from another that doesn't necessarily fit. Okay? So affinity chromatography is based on that specific attraction between the analyte and the stationary phase. Now again, the mobile phase here is likely to be a liquid. All right, so those are the primary kinds of mechanisms that we see in chromatography. And again, we'll see molecular exclusion. I don't want to spoil the theory for the group projects, so keep an eye out for those. And as we're going through different types of chromatography, keep it in mind which kind of mechanism each instrumentation is using.